Hello, everybody. Thank you so much for joining us today on a beautiful Friday afternoon. My name is Ludico. I'm the treasurer for PrISUm Solar Car Team, and I'll be your host today. To begin our agenda today, Michael Holm, our project director, and Rachel Eckert, our assistant project director, will be going over a short presentation of Eliana's development.
Here you see the beginnings of Eliana, initial renderings. These were established by team members several years ago, and the aerodynamic design was inspired by a dolphin.
After we started to get the aero shell figured out and rendered, we started to run some computational fluid dynamics on the aero shell. This program specifically is called Star CCM. It was donated to us by Siemens. Siemens is one of our biggest sponsors because they donate this software to us. We run these aero shells through CFD to make sure they're as efficient as possible, because when you're making a solar car, you want it to be really as efficient as you possibly can make it.
Here's some photos from initial manufacturing of our top and tub. Coastal Enterprises donated a lot of foam to our team. The top and the tub were a big undertaking to create because they're the largest parts in our car, and it took a lot of patience and sanding to get these finished.
So while all these molds were getting machined and we were getting ready to start actually building our car, some team members also started to work in virtual reality simulation of our car to make sure it was comfortable, we were able to reach everything we needed to reach, make sure the steering wheel wasn't too far away, really just basic car body stuff like that. The Iowa State Virtual Reality Application Center was the one that lent us a Oculus Rift so we could sit in the car virtually. This was really exciting because this was really the first time any of us really got to picture what it was going to be like to be inside Eliana.
For our molds process, we initially make what's called a plug out of dense foam. Then we make a mold based on that, and then create the part ultimately. So here are a couple images of our plug creation. George White was really kind in letting us use their paint booth for applying Duratec. Duratec is what we put on the plugs to ensure we have a really smooth finish, which ultimately makes our parts more mechanically sound and much more aerodynamic. And throughout this process, there was a lot of sanding that happened before and after Duratec. We used a lot of 3M products throughout the sanding process, orbitals, sandpaper, you name it. 3M was instrumental in providing all of those supplies.
So after we got that tub plug sanded and machined and Duratec, and it was looking really nice, one of our sponsors, Altec, made a fiberglass tool of it, a fiberglass mold of it. And we spent several weeks sanding down and buffing this fiberglass mold to make it as smooth as we possibly could. When you're using a mold, you want it to be really smooth because you're going to lay carbon fiber in there. And if it's too rough, you can't get that carbon fiber out, and you've just wasted a lot of carbon fiber. And so in that middle and right picture you see, that's us at the Delta Tech Ops facility in Minneapolis. They let us use their clean room for manufacturing our tub, and you can see that the room is pretty big, and they let us use their facilities to create these cars, and we're super thankful to them for that.
This is another picture from the Delta Tech Ops facility. When you're making a solar car, not everything goes perfectly all the time, and this is one example of that. When we first put the tub part in the autoclave, we lost vacuum. That cost us a lot of money in carbon and Nomex material, which put us in a tight spot trying to find sponsors to give us that material in a short amount of time so we could redo our tub.
And so after we failed that tub layup, all of our directors started reaching out to sponsors as quick as they could to try to get some carbon fiber to make this part and stick to our timeline. We ended up successfully making the part because we found why we lost vacuum, and we put that We put that carbon fiber into the autoclave and we crossed our fingers hoping we'd get a good part. As you can see in the left picture, that's our old mechanical director, Elliot Suter, testing the structural integrity of the tub by standing on it. If it can hold him, I'm pretty sure it can hold 1,000+ pounds of solar cars, so we should be good.
The suspension panels are one thing that make Eliana unique. This was a senior design project sponsored by Boeing that was happening when I first joined the team a few years ago. Rather than going with traditional suspension attachment, we chose a more lightweight option, attaching the suspension with carbon fiber, Nomex, and adhesives. Again, a lot of those adhesives were provided by 3M. This was significant because it saved a lot of weight. We also did extensive testing on this as part of the senior design project to ensure that this would be a safe design in our car.
So after we started getting those structures and suspension panels put into the car, we went up to Sind Customs in Minneapolis, and they helped us weld our roll cage together. There on the left is us actually in their shop getting our roll cage welded together. You can see in the top left of the picture, that's our roll cage. And then on the right is Sean Collins sitting in our new roll cage, very excited about having something that's finally starting to look like a car. You can see he's holding the steering wheel with a big smile on his face, and this was really just an exciting time for all of us because the structure of the car was finally coming together.
Painting the tub was an exciting moment because after all of that sanding and part preparation, our tub finally started to look like an actual car part. This was done by Quality Manufacturing Corporation in Des Moines. They did an excellent job. They were incredible to work with and really made our car look more professional.
And so that paint job brought us around to the start of the next school year. And with the start of my sophomore year, we started focusing a lot on recruiting because all the new freshmen were coming in. We wanted to tell them what we did on the solar car team. And so on the left is our car, what some people thought was a boat at the time, sitting on Central Campus. And then on the right, that's us at the Donuts with the Dean event in the 2019, seems like so long ago. And that gave us a good chance to show Dean Easterling what we were up to with our car. And it was just a very fun time to update the university on where we were with our car.
This is a picture from an outreach event at an elementary school a couple years ago. I first learned about the team from an outreach event when I was in middle school. Michael first learned about the team and decided to join when he was 5 or 6 years old from seeing the car in the Visha parade, which demonstrates the impact that outreach can have. We realize what an impact it can have on young kids now, and we want to make sure that we're showing kids what we're doing and inspiring them. Additionally, it's really valuable for the community to see what we're doing. During COVID, outreach was difficult to do. We didn't have many in-person options, but it was still a high priority for us. We took every virtual outreach event opportunity that we could and still managed to do a fair amount of outreach during COVID.
So this entire time, we also have an electrical team. Most of the pictures I've been showing so far are work of our mechanical team. That's because in the early cycle of Eliana, people were not great at taking pictures of the electrical team. And so these are about the earliest pictures I can find of this project cycle. There on the left is Doug with some boards that just came in. That's pretty early in our design cycle. You can see he's pretty excited about starting to get some designs in. By the way, Doug, the beard is an improvement. You look much more mature. And then on the right is a picture of our electrical team back then. That's about 2 years old at this point, so there's some people that have graduated, there's some people that have dropped off, and we've gotten a lot of new members. And so electrical team has been continually evolving, but they really have done a lot on this car that pictures so far have not justified.
Here's some panel fit testing we did once we had a lot of car parts complete. It was a little tedious at first. We just held the panels together, held them in place as well as we could with duct tape, but it was still an exciting time because that's when our car started to look less like a boat and more like a car.
And I just want to point out that picture on the right. That's our structures manager, Nick Schnebelin. This is one of my favorite pictures that was taken in our entire project cycle. I love his face, and we created a little bit of a joke out of it on our team because his face is just so funny to look at. Sorry, that wasn't an insult. And so along with this, we started to get some of our suspension assembled. Our suspension, we designed ourselves. We did FEA on it ourselves. We're given a lot of regulations and rules for what our suspension has to be able to sustain by the race organization we're under, which is the American Solar Challenge. And so after we started to get these designs done with our car, we started to outsource them to a lot of sponsors. We have so many parts that we're just not able to machine them all. We did machine a few in Boyd Lab, but most of our parts we outsourced to sponsors. Sponsors like Geeter Machining and Manufacturing, American Waterjet, Morgan and Meredith, Arconic donated a lot of material to us, so did Alcoa. Really, there's just a huge network of sponsors that helped us get this suspension done, and I'm eternally grateful to them, and I suspect that the rest of the team is as well, because these parts would never have gotten done without their support.
These are a couple images from finally attaching the panels. Panel attachment went very smoothly thanks to well-planned molds and fabrication prior. One exciting thing about Eliana is how much weight we saved from panel attachment. Because the panels fit so well together, we didn't have to use a lot of filler material to compensate for gaps. That saved a lot of weight, which is so valuable for efficiency of the solar car. And after we attached those panels, we did do some body working to further make sure that the aerodynamics were what we wanted them to be.
So after we got all these panels attached, we prepared the car to be finally painted. On the left is the result of several weeks of work by our team, working on priming and body filling. Rachel had said we didn't need to do much body filling, but we did definitely have to do some. And one of our main focuses was trying to keep the skin of the car as smooth as we possibly could. And once we bring it out, if you people in person want to come up and look at it, the paint came out quite smooth, and we're all very pleased with it. And a lot of that was the result of Quality Manufacturing Corporation, again, supporting us by painting the rest of the car for us. That picture on the right is a picture of us in their paint booth, and they're just painting our car, giving it a nice service finish.
Here are a couple more pictures from E-Team, and there are two things I want to note on this. First, you can see from the wizard hat, E-Team knows how to have fun. They add a great culture to the team and just make everything more fun. And secondly, both of these pictures are of Joe DeFrancisco, who recently graduated, so he is a Solar Car alum now. Our alumni are incredible. It's amazing to have a community of people who have been in our shoes and are supporting us. A lot of them have been in industry for a couple years or a while and are just really smart. It's really valuable to have them come back for the occasional design review or answer a couple questions, help us figure out how to use software. And I'm excited when I graduate to get to be a part of that community. It's really incredible to have that.
So this entire time, we're getting most of our work done at night. Everybody on the team has classes, and most people have on-campus jobs. And so that really only leaves evenings open and weekends. And so these are just a few pictures of some of our fun work nights. There on the right is a group of us at Blaze Pizza. And really, I just want to highlight the fact that all of my friends that I've met in college so far have been on this team. And a lot of my lifelong friends that I know I'm going to continue to stay in touch with for the rest of my life have come from this team. And I and everyone else on the team are very aware that we wouldn't have met each other without the support of the sponsors that sponsor our team. And so really, sponsors have changed my life during my college career, and I can't thank them enough for that.
I also want to point out one more quick thing about these pictures. You can see in the middle one, everyone is wearing flannel for no reason in particular. We just like to wear flannel for mech meetings. I didn't used to own flannel, but I went and bought some specifically so I could participate. It's just a fun tradition the team has. Here's another picture of a social event, this one being a barbecue pre-COVID. Another popular event was Sean's Tacos. We would have taco night, and Sean's Tacos were legendary.
So February 16th of 2020 was a big date for our team. It still is referred to as 216. It's a bit of a legendary date. And this was the first day we turned on our car. As you can see, there's no car in that picture. It was actually just electrically, everything was wired together, everything was communicating. We were seeing what worked, we were seeing what didn't work, we were seeing what had to be redesigned, and we were checking that our overall architecture logic was sound. Really, this day was super exciting because this was the first day where I really thought that, like, we're gonna finish this solar car and it's gonna turn on and it's gonna drive. Because up to this point, I'd just been working on a roll cage, and so seeing all these electrical components coming together was really exciting.
These are just a couple more pictures from turning the car on.
That's Andrew Bowen on the left, working on a board. And so during 216, there was also some talk about this COVID-19 thing. No one on the team really took it seriously. It was, diseases come up all the time, and then they drop off 2 weeks later. But then we got back from spring break, and we all got sent home. And we kind of realized that COVID might be a bigger deal than we initially thought it was. And so we tried to get done what we could at our homes. These are pictures of electrical doing testing that they could using their own stuff. Their own multimeters, their own oscilloscopes, because everyone on this team wanted to continue to do the work that they could on the car. Mechanical did what they could. They worked on designs, they worked on documentation, but really there was a lot of work that could not be done for several months. And because of this, our team focused really hard on trying to just keep everyone together and keep everyone friends. We had a lot of trivia nights, we had a lot of game nights, we had movie nights where we'd watch movies together on Discord or something like that. It was hard, but it was really fun being able to just socialize with the team while we weren't able to work on the car.
I am really proud of how the team did through COVID. When we came back in fall 2020, we had a lot of safety precautions to follow. We had limited access to our car, supplies, areas to work, and we did a great job of being strategic about following those safety precautions, but doing as much work as we could still. During this time, Austin Binder took the initiative to spearhead an entire strategy sub-team. This was a lot of work we were able to do virtually and still be really productive and prepare for race ahead of time. Really valuable addition to the team. We also got a couple meteorology majors on the team from that, which was exciting. Also during fall 2020, we got a rolling chassis. That was a huge milestone and really significant to accomplish in the midst of COVID.
Along with these mechanical developments, there were also electrical developments that make me just so proud of the people on this team for continuing to get work done while everyone had to stay at home and no one could talk to each other. And so on the left, you see the battery box finally getting assembled. There are a few modules in there that we had spot welded together. And on the right is C. Yun. He's very excited to have received his BPS boards that he'd been working on. He put those boards on all those modules and tested them and put a lot of work into making sure that they were going to make sure that our batteries are safe. And Sion did a good job.
And after all of that work just described, we finally reached the point where we could start testing. This is so important and valuable in preparation for our race. It's really good to hammer out as many issues as we can prior to July. Additionally, we have assigned rules for race that we've been able to test sort of practicing our roles and responsibilities to make sure that we'll all be ready for what our responsibilities will be come race.
And finally, on that testing night was the first time we drove Eliana. Those pretty little lights you see are Sion's module boards telling us that our batteries are not going to explode. And so that's always a good thing to see. And this basically brings us to the end of this presentation on the development of Eliana. This was a few months ago. We don't want to spoil the unveil by showing it in the presentation. So yeah, that's that.
We are so grateful to our sponsors for supporting us through all of this. When I first joined the team, when a lot of us first joined the team, the car was those renderings you saw on the first slide. It was an idea. It was abstract. We had CAD models. There was this abstract idea of one day we're going to have a car and we're going to go to a race. And after 3 years of believing in that, having faith in ourselves, and putting in work to create this car, it's surreal to see a driving car that can run under its own power. And the fact that we had to believe in ourselves and trust that we'd be able to make this car from the beginning of the process, and sponsors believed in us that we could do that as well, that's a big deal. And I really, really appreciate sponsors having that faith in us. That means a lot.
So I've got one last spiel on how much sponsors have done for us. As I've said before, my life is completely different from what it would be today if I hadn't joined this team. And I know that that is 100% because of the groups that sponsor our team. I've met friends. I've become a much better engineer. I like to tell people that when I first joined, I didn't even know what a 1-inch wrench was. I didn't know what that meant. Now I do. And I know that that all is because of sponsors that have supported our team. So thank you to all of you.
And without further ado, here is P15, Eliana, powered by Spectral Lab. You guys clapped too early. And I know everybody has a lot of questions, but we will have a Q&A panel shortly. So if you guys could hold on to those questions until then, that'll be great. We need...
So Nathan and Ashley are going to talk a little bit about our car.
Nathan Gladney is our mechanical director, and Ashley Robertson is our electrical director.
You first. Yeah. Yeah.
All right, so yeah, like Luda said, my name's Ashley Robertson. I am the electrical director. Now we're just going to kind of go over a bunch of the different parts of the car. So yeah, we're going to start with the exterior of it. One of the most prominent features, you know, it's a solar car. Obviously, it's going to have solar panels. So kind of hard to see from this view. On top up here, we have, you can't also really see the back too much. We have two different types of solar panels on our car. The first ones are XTJ primes. They are donated to us by Spectral Lab. And they are the, you know, one of the bigger, the more predominant cells that you will see on the car. We have a little bit under 800 of them on here. And on the back here, towards the end of the hatch, you would also see that we have Maxi and SunPower cells. And there's roughly about 70 of those that we have on there. And they're what power our car. They come in at about 70 volts, and then we bump it up into the battery pack. But yeah.
So now I'm Nathan. I'm the mechanical director. No, I have. Good job, Luda. Anyway, so as Michael and Rachel had discussed, as you can see in Eliana, she's very aerodynamically focused on the outside. Her aero shell is the main primary focus of the design when focusing on, the exterior of the car. So you can see there's a lot of swooping curves. She's very long and very wide, but very short to the ground to be as aerodynamical as possible. That was the main design on the mechanical side. Most of, and compared to our last car, P14, we switched from a four-seater to a two-seater now. So it should give you even more aerodynamic, and so there's less interior space, but we can have more spreading out all of the body area to make it more aerodynamic as possible. Do anything about outside else? Yeah, then we can talk about the inside.
All right, so yeah, so kind of going to like the front of the cab here, one of the main features of our solar car that we spend most of our time working on is our battery pack. So hopefully when people in person, when you guys come in, you're gonna get a closer look at it. You'll see a bunch of blue boards with some red underneath it. That is all the batteries that are in our car. It is an 150 volt battery pack, which is comprised of 35 different cell modules, and then each module is 36 cells in parallel. This is how we entirely power our car. It powers everything from the motors, the main thing, infotainment system, headlights. But yeah, and as you can see, they're blue lights when they turn on. The blue boards that you see on top of it is our battery protection system. This is basically how we make sure that our car is always going to be safe and not, in a potentially dangerous state. Like Michael mentioned earlier, that was designed by CYUN, and that monitors the voltage, current, and temperature of our battery pack, and it's always monitoring to see if there's going to be any issues that we should be aware of. Do you want to talk more about the mechanical side of the battery pack?
So the battery pack was designed in mind to withstand a 20G impact. So that was the main concern with mechanical. So it's entirely made out of a fiberglass enclosure. It was water jetted and assembled using more of 3M's adhesive products. It is designed to be as lightweight as possible, but it's strong to protect the batteries and insulate them from any other electrical, anything else electrically, so none of the electricity spreads out to the rest of the car, and insulate it from everything else. Yeah, I think that's about it about battery box on the mechanical side. We also designed a custom in-house ventilation system for that, where we use a exterior. We pull air from the side from these NACA ducts on the exterior here, and they pull into the battery box, where we use small fans to just cool it as most efficiently as possible, but keep the battery pack at the right temperature. But I think that's about it for battery pack mechanical.
One of the other things you'll notice too in the front, right front and center, where you can see the PrISUm logo, that is our infotainment system. So our infotainment system was donated to us by Harman, and it is a system that basically just adds a lot of cool functionality to it. Most modern cars have it. If you get in your car, the touch screen, you can plug your phone into. That's exactly what that does. So it gives us, Android Auto that you can connect your phone to. On top of that, we can also program our own applications into it. So we have an application that we can see exactly what's coming from our battery pack. We can see all the battery voltages, temperatures, and all that. And one of my favorite jokes on the team is that we're going to work on getting Doom programmed in. So when we're driving the car, the passenger could be playing Doom. But yeah.
Now more the mechanical, the most revolutionary thing with this car, like Michael had discussed, was that glued-on suspension there. In previous models and almost every other solar car, they had done physical attachment where they would use lots of screws and bolts to attach the suspension, and it's very clanky and it's hard to assemble perfectly. Whereas with carbon fiber here, we did carbon fiber and some of 3M's DP460 and 420 to glue on the suspension, which each side of suspension only has one bolt that actually attaches to the car, but the rest that attaches the actual suspension to the car is this adhesive with these carbon fiber stiffening panels across, which I believe were donated by Torre, if I'm not mistaken. Is that Torre? Yes, Torre donated all the support panels for the carbon fiber, which was crucial to making a structurally safe suspension that's not using any physical component, like any metal components to attach it to the car.
On top of that, the last main electrical system that we have up front here in the car is going to be our infotainment cluster, instrument cluster, sorry about that. And electrically, that just kind of lets us see some more on what's going in the car. We obviously can see how fast we're going. We can see how many miles we put on it. We can see what gear the car is in. Is it drive, park, reverse? And on top of that, we can also see if there's any fault states in the car. Like I mentioned before, our battery pack is always checking, the voltage, temperatures. So if our battery pack does sense an issue with that, it will shut the car off, and it'll pop up and say, hey, here's what your issue is. You might want to check it out.
And another thing that mechanical was the biggest stress throughout this entire build cycle is our roll cage. Our roll cage is completely made out of a chromoly steel, which is a specialty blend of steel that is wildly expensive, that is much stronger than a normal steel. But designing a custom roll cage for this such small and light car and keeping the roll cage as light as possible, because it was one of the more heavier components in the car, besides like the motors and the battery pack and the exterior panels, was a roll cage. So designing that with in mind of being as light and safe as possible was a struggle for us, but we throughout the past 2 years had worked on the roll cage. We've made additions onto it in the past year to make it stronger and more and to protect us better in there. But that was a crucial thing with mechanical design here. Dude. Hmm? Oh, yeah.
Or do you have more in front?
No, I really don't. Let's see, back here.
You really can't lift it up.
Yeah, well, can we lift it up?
Yeah, we can lift
Oh,
it up,
yeah.
and they can have the camera on the back.
Yeah. So,
I have one hand.
perfect. Yeah, okay.
So yeah, those in the audience can't see it, but hopefully the people on the live stream can. The back, there's pretty much one last major electrical component we have, and that is our motor controllers. Our motor controllers take the signal from our motor board, and motor board takes the signal from our brake pedals and regen pedal, which I'll explain a little bit more. And it takes those signals and it tells our motors how fast they should spin, what direction they should spin, and all of that. One of the things I mentioned earlier too was regeneration. That is our preferred method of braking currently for the car. So we have a button we have a paddle on the steering wheel that we can push, depending on how far we push it in. Obviously, the more that we will brake, and it will then tell the motors to, stop spinning, kind of send some current back, and then we can actually regen our battery pack using that system.
And one of the important mechanical components in the back here would be the hub-mounted motors here, which are directly behind the tires in here. They make a total of about 7 horsepower here. You don't need horribly much for such a light and efficient car, but those are attached within the suspension, so it makes them efficient since they are directly attached to the tires. It's the most efficient way you can direct a drive to a car like this. But that's about it for mechanical in the hatch there. You're good. I think.
That's it.
Yeah.
Thank you, Ashley and Nathan. Now we're gonna have a Q&A panel. So if you guys have any questions, feel free to ask.
I guess we go right back up.
Looks like we got locked out of the computer. All right, and then for our Q&A panel, we're gonna have Michael Home, Rachel again, our assistant project director and project director. Austin Binder will be up here from strategy. Nathan and Ashley, as you just met, for mechanical and electrical, and Brant for systems director. We do have 30 minutes allotted to this, but if you have questions, we have answers. If not, that is okay. So feel free to ask away. I'll also be on the live stream as well, so if you have questions there, feel free to ask on the chat box next to the video. All right, we do have a question from our chat box here from Cindy Gannon. I'm so sorry if I butcher anybody's name. Is there a sun run talked about for this summer?
So there was no sun run planned for this summer. We just weren't sure about the situation with COVID. As of like a month ago, it became pretty clear we probably could have had a sun run and it would have gone fine. But planning for that starts way more than a month ahead. I finish as project director about a month from now, right after our race, which is in 1 month. And Meg Lashir and Brady Wakefield will be taking over after Rachel and I leave after the race. And I really hope that they plan a sun run on the weekends, find some sort of way to work around the school year, but I can't tell them what to do. So as of right now, there's no sun run planned, but if we do plan one, you'll hear about it.
As Michael mentioned, with weekends and everything, even though we don't have an official sun run planned, will we still love to do visits where we can and to community events and sponsor visits where we can? Absolutely.
I do want to mention, if anybody has a question in person here, I will come and bring you the mic so that the live stream can hear the question as well.
Good afternoon. I have so many questions. I don't know where to start. Fabulous. This is really exciting. I guess start at the top. The mission, did I hear this was a 4-year vehicle?
I can't quite hear you.
Yeah.
The question was, this is a 4-year car, yes?
I think the speakers are pointed away from us.
Were you wondering how many years this car has taken to design and manufacture?
Yeah. Is it 4 years?
Manufacturing started in fall of 2018. There were initial design plans and renderings prior to that. And that's kind of a gradual process, so there's not an exact timeline of this is the date we started the car and but manufacturing started in fall 2018 and designs were completed throughout the year prior to that.
And then is there a culmination? Like what is your target? Is there a sun race or a American Solar Challenge, or what's the culmination here for Eliana?
So I'll go into that in better detail later on in this event, but we do have a race in about a month from now, and that's both the Formula Sun Grand Prix and the American Solar Challenge. I'll talk about that more in a little bit.
Thank you. We do have a question from the live stream chat from Evan Stumpjays. I'm so sorry again if I butcher your name. It says, how many miles are on the car so far, and how many are planned before the competition?
So we have about 40 miles on the car right now, and if anyone else wants to talk, you can jump in. We have about 40 miles on the car right now. Tuesday is the date that we're planning to become road legal. And so once we're road legal, we're able to, drive on the roads. Realistically, our mileage should go way up because we're able to just drive on the roads. Right now, we're driving figure eights in parking lots. And Evan Stumpjes is a American Solar Challenge official, and so he knows that we have to drive figure eights in a certain amount of time. We have to hit braking regulations. We have to hit slalom requirements. And so that's what we're working on right now. Just last weekend, we did a figure eight, and I can't quite remember the dimensions of the figure eight, but one of our members did the figure eight in 15 seconds with his SUV, which would take longer because it has a higher center of gravity and all that stuff. But we hit the same time with our solar car, 15 seconds, and the requirement is 18. So most of our testing mileage has been through trying to meet these suspension regulations. A lot more electrical testing is going to be happening in the next month.
Nobody in person has a question. Tyler Wegg in the chat asks, what's it like having a home base in the new Iowa State University Student Innovation Center?
That was something we transitioned to in, this past winter break? I think it was, okay, this past fall. It's been a blur this past fall. With it being a new building and moving in the middle of COVID, it was kind of a difficult transition, just assimilating and following COVID precautions, figuring out how the building works. But once everything is in place, we'll have an excellent composites facility that you'll see in a couple minutes during our shop tour, and you will get a better look at this during the shop tour that Nathan and Lucas will do. But we have gotten more used to working out of our space here and utilizing things like the composites room. The staff are great to work with, and yeah, we've adjusted fairly well at this point.
There are still things that are to be figured out with this building, as with any building when you first move into it. We had some trouble getting in on weekends and stuff like that, and trying to do work on the weekends when you can't get in. That's pretty difficult. But SIC is developing, and they're giving us access on weekends, and they're giving us more access to the composites room. And so what I like to say to people when they ask me about moving into this building is that I thoroughly believe that 3 years from now, this building is going to be one of the best buildings to have a solar car team in the nation. But right now, there are definitely some growing pains, but I very much believe it will get much better.
All right. So Elliot Suter asks, what's the final weight?
Well, last estimate with passengers and battery box and everything would be 1290. With battery box, no passengers, I believe it was 890 last we weighed, it was estimated, but we have not done a final weight because we have not had all the final panels done yet.
So that weight estimate got updated. It's now 1340. We're going a bit overweight with all this extra stuff we're adding to the car to make it look cool. But even 1340 pounds, that's almost half of what the last car was, which granted the last car was a 4-person car. But still, that wouldn't account for half of the weight. And so we're really excited that we're so much lighter than the previous car was, because we're showing that we're getting better at building these cars.
Thank you for that. Those are my questions too. So to key off of the weight, can you talk about, I guess you mentioned the payload briefly, but range on a full battery pack, like the planned hopeful usage for a car like this in the future?
Yeah, so I can address the range question. So a lot of that is going to depend on the results of our future testing that we plan with the car, but my current estimates peg the range at about 800 miles, including sunlight. Without sunlight, it'd be 300. So, yeah.
Do you happen to know what speed?
Going
25, 55?
Just above 35 miles an hour.
So we have a very specific question asked from Evan in the chat. Is J1772 charger working yet?
Can you repeat that?
Is J1772 charging working yet? That is a very specific question.
He's talking about the external charger plug. Ashley?
Oh.
Yes.
Yes, we have gotten external charging working. There is an outlet that we can use in the assembly bay that we have been using. We just externally charged the first time, was it last week? Yeah, so it does work. It was very exciting that we can now externally charge. Especially as we're ramping up testing, it's nice to be able to have a full battery pack.
To clarify for everyone else, SAE 1722 or 72, I'm forgetting the number, is exactly as the standard we're using for our external charge plug. So that's the specific plug we have to use to charge the car for race regulations.
Evan, are you asking about the current counter? I can't remember the technical term for it, but the way to count how much we charge our battery. I'm just gonna wait till you put something in the chat.
I think we should move on to other questions
Okay,
and come back to it.
Yeah, we'll come back to it.
All right. Matt Good asks, how does this vehicle compare against the vehicles you'll be racing against at ASC?
So we have been able to compare some of the race performances of this car against other cars. However, we have not gone too in-depth with that. It does look like it will be very competitive against all of those cars, however.
We have yet to get a lot of the critical numbers that we need for strategy for this car. Actually, about a year ago this time, we had a wind tunnel trip planned so we could get a pretty accurate CDA on the car. That trip got canceled because of COVID. And we're still working on getting rolling resistance numbers and things like that. So it's hard to say accurately.
All right, Karen asks, how many students are involved in making the car happen?
There are around 70 members on our roster, and going through our roster this past year, I'm impressed by how many of those members are active. Our race crew is 27 people, so that is a subset of our entire team, and those members are especially active, but it is around 70, and that's considering our business team, our electrical and mechanical sub-teams, our strategy sub-team.
All right, Matt asks, for each person on the panel, what is your favorite part of this vehicle, and what do you hope to do on the next car to make it better?
My favorite part is having regen working. Regenerative braking is really cool, and I really like that we have it working.
What do you want to do better on the next car?
Oh, what was the second part? Sorry.
What do you want to do to make it better for the next car?
For the next car, I want to work a lot on trying to make it easier to assemble. One of the reasons it took so long to put this car together was that these panels we've glued together, which have been really lightweight, were a pain to assemble. And they ended up not being very accurate. We had to get parts remachined because they weren't very accurate. We had to rerun FEA because they weren't very accurate. It definitely caused a lot of delays. And so I hope we can figure out a good way to improve on that for the next car.
My favorite thing in this car, because it's the biggest project I worked on, it's probably panel assembly. That was an enormous undertaking. There were many late nights and some sleepless nights involved in that. And I'm really proud of how we were able to accomplish that with work from a lot of people, and also got to work with alumni for that too, which was fun. Something I'd like to improve for the next car, this isn't a specific design component, but I would like to do more testing to prove that designs we have will be effective. I mentioned during the initial presentation, we did do a lot of testing for this car, but between the members who made the initial design and after all that time passing, the members we have now, there's some testing that was done a while ago that we followed up on using the same methodology used in tests, using the same materials, etc. But I think it would be really good to do some more thorough testing and research in the future to establish that a lot of our smaller details are really secure.
One of my favorite parts of Eliana is her paint and vinyl. I joined the team when her tub had already been put together, and right as the roll cage was being attached. So I was very hands-on with the paint jobs every step of the way. I went to QMC for every trip. I helped buff for hours. That was like my main projects when I was starting, was helping with those. So seeing it from start to finish with all that. And one of the things I took on this semester was getting all the vinyl for the car together and the paint jobs and all that. So seeing it all finalized and the beautiful red and gold that we have on there together is probably one of my favorite parts. But for P16, I'd like to see it to be a little smaller. You can't tell from a distance, she's really big. And it's difficult to fit in our trailer. We had issues with the molds being huge where and a bear to move around, and like barely fitting in the autoclave at Delta. There was many issues with her size and fitting her in places. So seeing her a little bit smaller, more manageable will be very appreciable for everybody who's worked on her.
So I think one of my favorite parts of this car is before I was on the strategy team, I was on the electrical team. And so I got to watch as different parts of the car came together electrically. And so I think seeing the battery box completely put together is like one of the most satisfying things to look at for me. And then in terms of things to change for the next car, not so much on the car, but more on like the strategy side of things. I think that even though our project has gone very well so far, I think there is always still more work to do. And so I'd like to see us like continue to develop more accurate ways of testing and verifying our numbers like against reality, specifically with regards to like solar panels. I think there's some more work that can be done there, but I think it will be very accurate for race.
So I guess for myself, I like the small little details. Every inch of the car, there's always been hours and hours of work put into it. And so seeing like the car shell, the roll cage, the tire, the suspension attachment, I should say, the brake pedals even, it's all beautiful. I don't know how many people can see it, but there are currently pink/magenta fuzzy dice in the middle of the car. And then the steering wheel. Both are pretty fun to look at, and those are very nice little cherries on top of our wonderful car. But as a more realistic answer, our entire occupant cell as a whole, and especially like the doors themselves, I would have to say the doors are probably my favorite part of the car right now. I mean, you have a flush handle, you pop it out, you open it, and it just opens. We've got a door handle inside, and it's smooth, and it's beautiful, and it's outstanding, the work that was put into it. As for what I would change or would like to see change for the next car, probably my biggest complaint is the occupant cell. You try fitting a 6'3" person in that car, you're not going to fit, except in the passenger seat. I get that's for efficiency reasons, and I get that I'm never going to be a driver, absolutely. But my gosh, we could really improve our egress and ingress a little bit, especially with like maybe lowering the battery box a bit, like maybe making it a little more flexible for room, maybe add a posable steering column, who knows? But just those little minor details to make sure our ergonomics for our drivers are really, really comfortable, because they're going to be spending upwards of 6 hours a day in those cars. We need to make sure that our drivers are comfortable, they're capable of being in there, and they're safe.
As for me, my favorite part of the board is definitely our car is pretty biased. When I was a sophomore and who knew nothing about circuits, the electrical director at the time, Craig Phillips, walked up to me and said, "Hey, you're in charge of pre-charge now." And if you talk to any person on the electrical team, it's a cursed board. It was awful. A lot of us put a lot of hours into it. But I mean, the reason it's my favorite is it's the first like hands-on project I've ever really got to work on that really made me feel like an engineer. And it's kind of the moment where I kind of really got to know the team. Like I said, it was the problem child of the car. We had a bunch of managers all like staring at it and we're like, we don't know why it doesn't work. We eventually figured it out, but working till midnight, 1 a.m., 2 a.m. with everyone, it's when you kind of start to all get close together, start to really, get to know people on the team and feel like you belong. As for what I want to see improved, for me personally, one thing I really want to focus on is battery characterization. It's kind of one of the major projects we're hoping to take up next year. We know that going in this car cycle, it was an area that we were lacking in. We had a group that tried to do a senior design project for it, and they realized that they almost it was a lot bigger of a project than they thought. Like I mentioned earlier, we have 35 different modules in there, 36 cells in a module, and your module is only as good as your weakest cell. So making sure that you know everything that you can about every individual cell and make sure that they're in the best possible place they can be, it's absolutely game changer and really sets you apart from the rest of the competition when you go on race.
I have one thing I want to add quick that I remembered. I said for improvement, I was thinking more in general, do more testing, not a specific design aspect. But something I would love to experiment with is a different roll cage material. We went with chromoly for this car, standard, reliable, but I think it would be so fun to investigate a strong, lightweight material for the roll cage and look into how we would weld that and how we would manufacture a material like that. That sort of thing would be so fun to look into.
Hopefully ASC allows composite roll cages. Evan, hint, hint.
All right. Evan asked a question. How fast have you been able to drive so far? Any concerns with hitting highway speeds?
So again, how far we've been able to drive? How fast? Oh, how fast. So I believe our current top speed is 29 miles per hour or 28 miles per hour. We are currently limiting ourselves and also giving us kind of a range restriction.
35.
Oh, wait.
35.
We got up to 35. That is the best news I've heard all day. Okay, so correction of that. We've been up to 35 miles per hour now, so that is our minimum requirement for mileage for ASC regulations. So I guess really all that's restricting us now at this point is road length. The roads we're testing on right now, our parking lots, they're too small. We can't drive that fast and that far yet. So we're at the point where we need to be road legal, and we need to get on the road and start driving far and driving fast.
A solar car does not have an impressive 0 to 60 time.
We're looking at probably, 2 minutes?
What is your plan for solar cell encapsulation? Looks like there's still protection needed there.
Yeah, so like I mentioned earlier, we do have 2 different types of cells. They each do have different encapsulation types. I will talk about the XTJs primarily, since that's the ones that we did in-house. If you actually look closely at the car, you will see that some of the cells, XTJ cells, look different. We actually done that when we were conformal coating. We were using one. I don't exactly remember the application process. I was not there while they were doing it. But it was a little bit bulkier. We eventually then switched over to, I don't know exactly what it is, but like a little jar conformal coating that we would just kind of paint on top of the cells. And then we did some testing to, see how much efficiency they would lose, make sure they were actually waterproof, and just by painting over the edges of the cell, we saw barely any, if any, efficiency loss. It was pretty minimal, if I remember correctly. And they were waterproof. We are doing more testing to make sure that it is sufficient right now, since it is recently completed. As for the Maxians on the back, which are the smaller, we have less of, those were done by Elaine.
Alan Chuziel at Suncat.
Yeah, at Suncat. He has some method that he uses to encapsulate cells for silicon cells. There's pretty commonly used. He has a method that makes it way lighter, more efficient than anyone else, and he's the person that encapsulated our cells.
He also gave us a big discount, so if you're watching, Alan, thank you.
Okay, and why the 2 solar cells?
So the main reason for that, as I mentioned before, the XTJs were donated by Spectralab. They are fantastic cells. They are high quality, top of the line. The reason that we added the silicon cells on there was just to kind of give us a little bit more power. We had the space to do it, and the XTJs are gallium arsenide cells. They are a lot more expensive, so they're silicon because it was cheaper and more affordable.
All right, looks like we have time for one more question. By the way, Evan did respond. He said, don't count on composite roll cages being allowed for ASC.
What did you say?
Don't count on composite roll cages being allowed for ASC, what Evan said. And then we'll just go down the line.
We'll talk later, Evan.
Smeet is asking low-key a dangerous question. It says, what are some of your favorite stories or experiences from designing and building the car?
You know what? I'll start off with. So Rachel, you remember that Delta trip, right?
That's exactly what I was going to bring up.
Yes. All right. So Thanksgiving, fall 2019. Was it the weekend before or weekend after the break?
Before.
So the weekend before, I think about 5 or 6 of us took a truck, 1 or 2 of them, went up to Minneapolis, Minnesota, Twin Cities, went to the Delta Tech Ops Center to do some wheel covers and composite panels, right? Yeah. Oh boy, let me tell you, that was a fascinating experience. I think we got 2 fairings done and a number of panels. A day and a half.
Or some sandwich panels.
Yeah.
Sandwich panels.
We got a lot done, and I think Rachel, I'll let you comment more on that one, but it was a fascinating experience.
Yeah. So Delta Tech Ops trips are across the team, have been for years, some of the most memorable experiences you can have on this team. We go there over the weekend or for a couple more days. We haven't been there for a little bit because of COVID, but those trips are some of the most intense but rewarding and fun and teachable trips you can go on. The professionals who work there are phenomenal in guiding us through the composites manufacturing process. There's stuff that we know to an extent, but they are geniuses at composites manufacturing. And it's crazy to see a layup that would take us, a layup meaning making materials out of carbon fiber and Nomex. Crazy to see them do a layup that would take us several hours in just 10 to 20 minutes. There's a lot to be learned on those trips. There is a lot of sleep lost. There is a lot of adrenaline that comes into effect. And Delta trips are some of the best memories I've had on this team.
Depending on the trip, there might be a little more than just sleep lost, but it's a good experience.
My favorite memory is actually when that tub failed that we talked about earlier. That's the most stressful moment in my life. That's not an exaggeration. My freshman year, I was going on Delta trips almost every weekend, getting these panels built. And seeing that tub fail was really sad and very stressful and very hard. And seeing Elliot Suter and Smeet Mystery step up and kind of say, well, we got to get this car done, and just throw themselves into trying to get carbon fiber donated was really impressive, and honestly still inspires me to today, because I mean there's a crisis every other day trying to get this car done, and just seeing them do that when I was a freshman really inspired me.
I know for me, my favorite experience personally was 216. Again, it's one of those cursed days on the team. As you guys saw in the photo, it doesn't really do it justice to how it was. The electrical team works in something that we like to call the cage. It's a Hoover 3202. It's just a shared club room for a bunch of electrical engineering clubs, and we packed it to the brim. You could like barely move around. This is pre-COVID, of course. It was a great day. Everyone was there, and it was the day that we all decided we were going to start the car. And as you saw in the photo, everyone was like around a table, trying to figure out what was happening. But what you didn't see was me, Doug Zurcher, and Brian Kalkoff in the corner, again working on pre-charge, the cursed board, just kind of staring at it. We would had it all day, just wondering why it wasn't working. And I'll never forget, it was the day after 216. We plugged it in the car, expecting it to fail like it had been for weeks on end. And the one way that we know that our car turns on is you hear two clicks from the relays, the negative side relay and the positive side relay. So, we do the button, we start like the whole turn on process, and then we're like, all right, we hear two clicks. And it did not process in our heads what had just happened. Like, we're sitting here, we're like, two clicks, what does that mean? Like, what just broke? And I think it was Doug just sat there and he's like, wait, we just turned the car on. And I don't know, it was just that one moment, the first time it turned on, it took us like minutes to understand what had actually just happened because we were so defeated. And it was exciting. We started freaking out after that. And that's kind of when things, started to really ramp up. We started turning, it started happening more frequently. Then we started building a battery pack. And it was just really exciting.
I think one of my favorite memories, so before getting Eliana painted at QMC, after we had her primed and all the panels on, we were frantically filling all those like little holes from the carbon fiber from the mold. We were just bondoing and just sanding these little portions down, trying to get the car perfectly smooth. And we were going hours on end. I think I was starting work at like 7 a.m. and I don't think I left
that facility until, I want to say, 4 or 5 a.m. the next day. Just consistently bondoing, sanding until we got the car perfectly smooth. But in this process, we couldn't see the divots as well enough because it had been black painted, so you couldn't see the reflection. So like right above the windshield, I was sanding up there and sanded a little too much. It made a little divot that we didn't notice until after the car had been painted. So you ever notice a little divot above the windshield? Yeah, that was a little screw up that we had because we were just like trying to make it perfect and just didn't notice that little bump, but it's a little mark on the car.
Yeah, and I think for me, my favorite moment actually happened a couple weeks ago when I went out to Jack Trice to see everybody testing the car and check in and see how things were going before working on some strategy stuff. And I saw Doug, and he just said, "Hey, want to drive the car?" And I was like, "What?" And then I got to drive the car, and it was like really like a magical feeling to like actually turn it on and see it like actually move, like because you push the pedal on a car. That was probably one of my favorite moments.
Okay, I have one last thing before we wrap up. On the note of testing, past couple of weeks, we've been doing a lot of testing, which has been great bonding time for the team. And the other day, I saw a message in Slack from one of our freshman members saying, just wanted to say, these testing nights are genuinely some of the most fun I've had on the team so far. And going towards race, the testing we're doing, and the team morale has been so awesome to see and experience, and it's just getting us really, really increasingly excited for race.
And yeah, I'm sorry, Luda. I'm so sorry. But could we actually have a round of applause for the test crew that have been here every weekend for this entire summer so far, just putting in hours and hours of work to make sure that this car showed up at Unveil as pristine as it is today. So just a quick round of applause.
And that will wrap up our Q&A session. Thank you so much to the panel here. We will now be transitioned to our shop tour, which will be led by Nathan, our mechanical director, and Lucas Pearson. Lucas Pearson, our system mechanical director. And this will be our transitional period. If you're on the live stream, please stay on. We'll be transitioning, and then we'll be right back on. And if you're in person, if you guys would like to follow our two mechanical directors, the shop will give you a little tour.
storage for all of our work equipment we have.
Another thing to mention is we just walked over there. It's maybe a 45-foot walk just from where we meet usually to come over here. It's really helpful. After mechanical meetings, we talk about something we want to fix or look at on the car, and then we can just come in here, don't have to drive anywhere like before, and start working on the car.
Also, we now have a specific welding area, which is very helpful to have when we do get to welding stuff again in the future, when we get to that point of the next car. But yeah, that's about it for, this is main area of our work area. We do most of our work day to day, and where the majority of the time Eliana stays.
Yep, and then we have a garage door here, which is really convenient when we need to move the car up and go into the trailer. There's actually a freight elevator right in the corner where we can fit the car in, and then just bring it up the floor and go out of the building.
Cool. What? Oh, we're still waiting on.
And then just in a minute here, we're going to go take a look at our composites room. That's where our layups happen. The room has negative pressure and then a lot of room in there for a freezer, oven. So eventually we'll be doing all of our composite stuff in there.
We're just waiting for them to unlock the door. But so it's really nice to have an actual clean room. In our previous facilities, we didn't have any specific areas that were meant for doing layups at a more frequently how we've been doing them. And it looks like they're just about to open the door to the composites room. Here we go. So this is the composite room where we do a majority of our layups. So we actually have dedicated tables and storage space for all of our materials in here. And in the back corner there, we have our composite freezer, which currently isn't working, but in the future we'll be able to store our pre-preg carbon fiber, which is what we made majority of which made our entire tub and all of our side panels and roof panels out of pre-preg carbon, which needs to be stored in an industrial freezer. And anything else about the composite room then?
That's about it. We've got a bunch of lines for compressed air in case we need to blow stuff off. This is actually where we did some sanding for the car. We can just bring it in right here. Yeah.
And
I think that's pretty much the end of the shop tour then.
All right, so now that we're done with that shop tour, we have one last section, and I'm just going to overview our race in 4 weeks, what it's going to entail, where we're going, all that juicy stuff. So the first race we're going to be participating in is called the Formula Sun Grand Prix. This is going to take place in Topeka, Kansas, specifically at the Heartland Motorsports Park. The dates are going to be from July 27th to August 1st. Technically, the dates of the race are July 30th to August 1st, because those first 3 days are spent doing something called scrutineering, where the ASC officials, Evan and others, inspect our car, make sure it's safe, make sure it meets all the rules that we're required to meet, make sure it meets all those suspension rules that I had mentioned earlier. They look at our electrical design, they look at our battery pack. Really, it's a very in-depth review of this car to make sure it's safe, and to make sure it's reliable, and to make sure that we're not cheating with how we've built the car. And so after scrutineering finishes, assuming we pass it, we will start a track race. And this track race is going to take place from July 30th to August 1st. And the track race is really like any track race you could imagine. We're going to focus on getting the fastest lap. We're going to focus on getting as many laps as we can. It's a bit of an endurance track race. We race for 6 hours a day. It might be 8. I might be wrong. And so we try to get as many laps as we can. We try to do it as efficiently as we possibly can. We get penalized if we charge our car from like a wall outlet. We're trying to charge it all from solar cells because we're a solar car. And so at the end of that event, whoever did the fastest lap, whoever had the most laps, all that stuff, they all get awards. And if you do well enough at this event, you qualify for the American Solar Challenge. The American Solar Challenge is taking place from August 3rd to August 7th. You may notice there's a gap day in there, and that gap day is going to be a show day where basically we just display our car for the ASC officials. They look at it, and this is also open to the general public. Everybody takes a look at it, and the ASC officials have this secret metric that they measure the practicality of our car by. It changes every year. It changes every race cycle. And so we try to just make our car as practical as possible. Features that could be considered practicality are that Harman infotainment we mentioned. We'll also have Harman speakers, so that could be considered practicality. I laid in some carpet last night. That might be practicality. I don't know. Maybe they really like carpet. And so we just try to make the car as comfy as possible. But getting back to the American Solar Challenge, that's going to be a 4-day race. It goes from Independence, Missouri to Las Vegas, New Mexico. And it's going to follow the Santa Fe Trail very closely. That's Las Vegas, New Mexico, not Nevada. I made that mistake for like a day, and then I noticed my mistake. But that trail passes through a lot of historical landmarks. Official track details, our official route details have not been released yet, but we have stage stops for each night. And we can assume that it's going to follow the Santa Fe Trail pretty closely. And so while we're on this race, if you want to follow what we're doing, we have social medias on Instagram, Twitter, and Facebook, all called PrISUm Official. We'll be posting daily race updates while we're on this race. So if you want to follow it, if you want to see what we're up to, feel free to. Yeah. And finally, as we're getting ready for race, I really want to be able to take race crew out for dinner at the end of race because they've all worked super hard. And so if you want to support us taking people out for dinner, there's a donation link right here for our team. I'll copy and paste it and put it in that YouTube live chat if you don't want to type this down. But yeah, that is the end of the presentation. That's the end of our unveil, and thank you for coming. For the people in person, you can feel free and come up and look at the car. We'd like to be out of here by 2:45 at the latest. We're giving rides at Jack Trice Lot S5 if you'd like to ride as a passenger in the car. And with that, thank you.